Hello everyone, wrote on electromagnetic induction. What is electromagnetic induction? In one line, we are interested in inducing EMF. So in the whole chapter, you will find that anything which we do is related to inducing EMF in a circuit. Now, how do we induce that EMF and how do we explain that is something which is important. And one special thing, this chapter is nothing new. You can develop everything with the help of all the concepts of electric field and magnetic field which you have developed so far. So let's start with a very basic thing and you will understand what does it mean when I say inducing an EMF. Suppose we have a rod. You don't have to note down anything, just look at the figure. It's a rod and this rod is moving in this direction with velocity v. And when it is moving in this direction, in the entire region, a magnetic field is present which is pointing out like this. For the time being, you can take that magnetic field is uniform and then we'll develop different cases. So you have a rod of length L, it's moving in this direction with velocity v in the presence of this magnetic field B. Now, you know that on this rod there are free electrons present. So these dots which you see, they are representing free electrons. The electrons which can easily move. Now, you have done Lorentz force. So I'll ask you and give you 30 seconds for that. If you move this rod on which these free electrons are present in the presence of this magnetic field, then what is the direction of force which is acting on these electrons? Your time starts now. Let's see how many of you can answer this. And as I told you that nothing new you will see in this chapter, at least in the beginning. So you can develop all these things with whatever you have got so far from electro and magnetic field. So this is coming from Lorentz force. The question is, these electrons, they are being pushed by a force coming from this magnetic field. And I'm asking you, what is the direction of that force? There is only a single response so far. I'll give you another hint. How do you decide direction? With the help of cross product or with the help of FBI? Use FBI and get me the direction of magnetic force. I have taught you how to use FBI. When you participate like this, you will learn. Otherwise, if I have to write everything, then it will be a difficult task to understand all these things. FBI, F, B, and this is the I. F, B, I. B is pointing out. B. Electrons are moving that way, but electrons are what? Negatively charged. So the electrons are moving that way. We take direction of current this way. Electrons are moving that way. Equivalent current will be taken in the opposite direction. So this is I. This is B. What is this? Direction of force. So on these electrons, a force coming from magnetic field is present in the upward direction. Only 3-4 even tried to answer this. So rest of you who could not, they have lot to learn. And I will request you to work hard. If somebody is not able to figure out direction of magnetic field, magnetic force, then kind of they are struggling. And if you are a struggler, then you will get passing marks only. Don't take it otherwise. I'm just giving you an idea that buckle up, you need to do something about you. Now look here, these are the electrons, and these electrons are pushed up by this force coming from a magnetic field. Now what will happen? Because of this, on this rod, negative charge will appear over here. These electrons, as they move this place, it becomes what? Negatively charged. And since electrons are moving this side, this place will become what? Positively charged. I hope you can see plus plus, minus minus, because of this force. Now if you remember capacitance, charging of capacitors, after a particular time, if you remember, we found that charging stops. Something similar is happening here. As this magnetic force pushes these electrons from this side to this side, making this side negative and this positive, third electron, let's say 2 electrons have reached this position, and third electron starts going up. As it goes up, these electrons which are already present will repel this third electron. So let's say this is the third electron and it is going up. You don't have to show it, just for your understanding. So this electron is being pushed by the magnetic field. You're moving the rod in this direction. A continuous force is present which moves this electron up. But these electrons, they are going to repel this. At the same time, these two positive charges, say protons, are trying to attract this electron. This is called force coming from electric field. So what is happening? This electron is being pushed in the opposite direction of this magnetic force. And that force is coming from what? From the electric field. How do you produce electric field? You've got negative charge, you've got positive charge, and because of negative charge and positive charge, you know there will be an electric field in this rod. Let me see if you can answer this simple question or not. What is the direction of electric field in this rod? Up or down? Write down this in the comment box. And remember, I am asking you something which is very elementary. Somebody even from class 10th can answer this question. What is the direction of electric field in this rod? Good. Direction of electric field is up, shown with this red arrow. This is the direction of electric field. What is the direction of electric field? Away from positive charge towards the negative charge. This is the direction of electric field. I hope you remember this. Electric field, its direction is away from the positive charge and is towards the negative charge. Now the third part. Because of this electric field, there is a force on the free electrons. What is the direction of that force? Write down your answer in the comment box. What is the direction of electric force on these electrons coming from this electric field? Now, electrons are what? Negatively charged. So electrons are negatively charged, and on a negative charge, force is opposite to the direction of electric field. So direction of force because of electric field will be downwards, like this. These are simple objective questions. They will give you a rod which is moving in this direction. They will ask you what is the direction of electric field. That's the direction of electric field. They will ask you what is the direction of electric force. That is the direction of electric force. So, what is happening? This electron, let me show this electron over here. If you draw free body diagram of this electron, which means if you are showing forces on this electron, then this electron is under a force of magnetic field FB. At the same time, this negative charge is repelling it in this direction. This is the repulsion. This positive charge is attracting the electron downwards. This is the direction of attraction. So you have a force of electric field in this direction. Now, but initially force coming from magnetic field is dominating, and therefore this third electron reaches this position, making this side 3 negative, making this side 3 positive. Now, as magnetic force starts moving fourth electron, now there are 3 electrons which are opposing the fourth one. Listen again. When third was being pushed up, only 2 were opposing it. Now when fourth is being pushed up, 3 are opposing it. That means a time will come when these two forces are of same magnitude. Gradually, force coming from these electrons and these protons, for the time being, let's say protons, is increasing. Once this force of magnetic field and force of electric field, they are equal, we call it equilibrium. At equilibrium, force coming from electric field will be equal to force of magnetic field. What do you mean by equilibrium? Equilibrium means total force is zero. Ft is zero. This force is equal to this force. There is no net force. Ft is what? Zero. So Fe is equal to what? Fb. This tells us this. What is Fe? Force of electric field on a charge is what? QE. What is QE? Force coming from magnetic field. What is that? Q V B sine of 90. Lorentz force. V B, an angle between V and B is what? 90. So this is force of electric field, this is force of magnetic field. At equilibrium, they both are equal. If they are equal, Q and Q cancelled, you get electric field which is coming VB. So we have got the strength of electric field. And once you got the strength of electric field, now again remember electrostatics. This end, let's call it A. This end, let's call it B. This is A, this is B. We are interested in finding VA minus VB. VA minus VB. This VA minus VB will be called E. This is induced EMF. This is what? Induced EMF. Just to differentiate this from this E, we have shown it like this. So this VA minus VB is E. What is this? Induced EMF. Now what is VA minus VB? What is potential difference? If you have the idea of electric field and if you have the distance between 2 points, then I want you to write down in the comment box what is VA minus VB. What is VA minus VB in terms of E and distance between A and B, which is L. Write down this in the comment box fast. And remember, I told you that this is all about previous lectures. And look, this is the first response. Only a single response so far. It's almost become a practice now. So I will again say the same thing. Practice a lot. Many of you are simply struggling. You don't even remember things like these. This is coming from electrostats. There were 2 points 1 and 2 separated by a distance of d. Potential at d, potential at 1 is V1, potential at 2 is V2. Then V1 minus V2 was E multiplied by d, where E is electric field like this. This is coming from electrostatics. V1 minus V2. V1 minus V2 is E multiplied by D. So, what is VA minus VB? E multiplied by D. In this direction, you have an electric field E, and distance between these 2 points is what? L. And therefore, this is coming E multiplied by L. We have already found the value of E, which is VV. That makes it induced EMF as V into B into L. This is force of magnetic field. This is entire length of the rod. We have developed an EMF which is VVL. So far we use a battery to develop potential difference. This time, instead of using a battery, instead of using chemical reactions, what we are doing, we are holding a rod and we are moving this rod in the presence of magnetic field. Pick up anything, and the moment you move it, you're moving it in the presence of Earth's magnetic field. And since it's moving in the presence of magnetic field, even this marker, as I move it, it will get an EMF of VBL, provided angle between V and B is 90. We'll see that later. This whole thing is something which we are going to study in this chapter, electromagnetic induction. So what we are doing, we are inducing an EMF. We are inducing an electric field with the help of a magnetic field. If you understand this much, then write down yes in the comment box and note down everything. Now write down a statement. When a rod moves in the presence of magnetic field, when a rod moves in the presence of magnetic field, an electric field develops in the rod, an electric field develops in the rod, which in turn produces an EMF, which in turn produces an EMF. This process of inducing EMF, is called electromagnetic induction. In just 30 seconds, let me explain the whole thing again. As the rod moves, these electrons along with the rod, they start moving in the same direction. If a charge moves in the presence of magnetic field, then from Lorentz force we know that FB will be present. This magnetic force moves these electrons, creating a polarization. Because of the polarization, an electric field develops. Because of the electric field, an electric force develops on the electrons like this. Gradually, this thing, its strength increases. As more charge accumulates over here, strength of electric field increases, and therefore this force, its strength also increases. Then, at equilibrium, no further polarization can take place because these two forces are simply cancelling each other. At this equilibrium, we say that total force is zero, which gives us the idea of electric field which is present coming as V into B. If we have the electric field, then this is coming from potential difference in electric field. It tells us that potential difference VA minus VB, you don't have to confuse with negative and positive. You can see that this end is what positively charged, this end is what negatively charged. So VA minus VB will be definitely positive. So that is coming VBL from this. Now it's a special result also, and you will remember that if you have a rod of length L, which is moving with velocity V in the presence of magnetic field B. If you look at these three markers, I hope you can see that all three are mutually perpendicular, which will be a special result for us. So if you have V, B and length, all three mutually perpendicular, then induced EMF will be VBL. It can be plus, it can be minus. If somebody says find out this minus this, If you subtract from this thing, then answer will be what? Negative. Magnitude wise, VBL. Let's write down the statement, although we'll again come back for this statement, but let's write down this thing over here also. If V, D and L all three are mutually perpendicular, V, D and L all three are mutually perpendicular, then magnitude of induced EMF is simply VBL. Now let's develop this whole thing with the help of vector analysis. So this is a special case. V, B, L, all three are mutually perpendicular. What if they are not? So for that, let's develop vector form. Write down vector form for induced EMF. Vector form for induced EMF. Now, remember that EMF is a scalar quantity. So we are trying to develop a vector form which should give you a scalar thing. We are interested in vector form, but ultimately it should give you the scalar quantity. This figure is now just for your understanding so that you can relate with each and everything we do. This new format is applicable for any type of situation. Look, Lorentz force in its complete form is given by this. QE plus Q times V cross B. This is a complete Lorentz force. If both electric field and magnetic field are present. If only magnetic field is present, forget about this. If only electric field is present, forget about this. If they both are present, note down both these things. So, this is the Lorentz force on these free electrons at equilibrium Now, just remember these directions and all. This was the force of magnetic field. This was the force of electric field. This is your free electron. This was the direction of electric field. for this particular setup. So we are keeping this setup so that we can verify everything coming from this part. At equilibrium, you know that F is what? Zero. Total force. So at equilibrium, this F, what is this F? Total force. It becomes what? Zero. So this is zero. You're saying QE plus Q times V cross B is basically zero. This thing is zero at equilibrium. Q and Q cancelled. This is zero. This gives us electric field as minus of V cross B. Q gone. Shift this thing over there. E is what? Minus of V cross B. What is this? Cross product. What is this? Negative sign. If I take this negative sign inside, then it gives me E as B cross V. If you change their positions, this negative sign can be removed. This is E, which is an important result for board examinations, NEET as well as JEE Main. Don't forget to write result. This is E, which is B cross V. Note down this much fast and then we'll find the induced EMF. I'm giving you a 30 seconds work. You've got electric field as B cross V. And we already got the direction of electric field. Using cross product, you have the direction of magnetic field, you have the direction of velocity. Using cross product, verify the direction, and if you get the same direction, then write down yes in the comment box. I hope you understand what I am trying to ask you. This is the result. If somebody says find out direction of electric field, you don't have to show these electrons and all. You can find that using this B cross V. So once you get the same direction, you will write yes in the comment box. What is direction of electric field? Always perpendicular to the plane of B and V. This is B, this is V. I'm holding these markers like this. B and V. Keep them in your left hand. Have your right hand free because it will be used for curling. Curling from B to V. This is B to V. Thumb is up. B to V. So this is B and this is V. Thumb is coming up. And nobody pointed out and everybody is writing yes. This was not the direction of electric field. So when I change from this side to this side, this is the direction of electric force. This is not the direction of electric field. And nobody corrected me. But cross product, it did correct me. What was the direction of electric field? Direction of electric field was this. Away from positive towards negative. This is the direction of electric force. So, V cross V, that's the advantage of maths. It will take care of everything. Even if you are confused, even if you are committing silly mistakes and all, leave everything to maths. It will take care of the whole thing. So this was this was B, magnetic field, and this is V. Your electric field can be either up or down, perpendicular to this plane, up or down. Now how do you decide that? Hold your right hand like this, thumb up or down. If thumb is down, then you are curling from this side to this side. If you keep your thumb up, you are curling from this side to this side. Now this is B, this is V. And the curling should also be from B to V. That immediately tells you the direction of electric field is up. In this case, and now for any case, you have the idea of electric field. Now, the moment you got the electric field, I'm removing this. Once you have the electric field, and I ask you to find potential difference, then I hope everybody remembers this. dV is equal to minus of E dot dr. Relationship between electric field and potential difference. If somebody is confused, doesn't remember this, then after the class, just send a request and I will give you the lecture where I explained all these things. And this is nothing but work, change in energy. So dV is minus of E dot dr. How do you use this for a given setup? First, what is the meaning of this? At a distance of r, at a distance of r, if you take a small dr, a small element dr shown with blue, at a distance of r, you take something of small length dr. Right here, potential is V. Over here, potential is V plus dV. That's how maths works. At R, you have V. At R plus dr, you have V plus dV. At X, you have Y. At X plus dx, you have Y plus dy. And what is difference of potential between this point and this point? dV. What is that? Electric field in this region is E. And to be more precise, if you can see the green marker in this region, in the region of dr, from this place to this place, electric field is E. This is E vector. This is the direction of that electric field, which is over here. At this place, some other electric field will be present. At this place, some other electric field will be present. For the entire length of dr, you have this much electric field, which is given by E, then potential difference between this point and this point, which is dV, is given by minus of E dot dr. For further detail, I have told you what to do. Now, if in our setup we use these things, then the way you will use it is something like this. Look here. Let's take a large length, and what we did, from this place to this place, we have taken L vector. Just don't worry if you are a little bit weak in differentiation and integration sort of things. Just don't worry. Ultimately, you will get a standard result. But maybe if you are weak in these things, the same approach will help you a lot. At a distance of L, take a small length dl. This is dl. Look at the similarity. R dr, L dl. Potential over here is V. Potential over here is V plus dV. So I could have given you this thing direct, but I explained this part coming from Electro, which is coming from 11th work power energy. So this is L, this is dl. If somebody tells you find out potential difference, you will write dV minus of E dot, replace your dr with dl, E dot dl. It's not difficult at all. Replace dr with dl. Everybody has seen this formula. Now what is minus of E? Take the negative sign there. If I move this negative sign over here, this is what? Minus of E. And what is minus of E? V cross B. So this is V cross B. Minus of E is V cross V. Minus of E is V cross V dot dl. This is the vector form of induced EMF. This is we have for small element. Now you don't have to worry about whether things are uniform or not. If things are uniform as they were in the very first example which we took, all vectors are perpendicular, you got a straightforward result, VBL. But if magnetic field is non-uniform, you don't have a straight wire, things like that, we will come and take help from this format. This is something which is called vector form of induced EMF. I could have given you this dV straight away after this. I would have said, you remember dV as minus of E dot dr, replace dr with dl, and then I could have produced this. But I want you to remember meaning of each and everything. What is the meaning of dV? dV is potential difference across dr. What is that which is producing this potential difference? Electric field which is present in this region. So what is that which is producing potential difference across this dl? Across this dl, the thing which is producing potential difference is the electric field E, which we had shown with this red arrow. So in this portion, you have your electric field and this electric field in this region is producing this much potential difference. Note down this much. And if you are comfortable with this vector form, then write down yes in the comment box. If you are not, write down no and ask me, tell me exactly where are you confused then. And remember, I can always save time if I do not tell you these minute things, then it will save me a lot of time and energy, but you will not get any benefit out of it. Now the thing which you are going to be asked mostly, and before that, I hope you have written everything. This dV dV, this is capital V, potential difference. V, velocity. B, magnetic field. Dot dl. Keep it inside a boundary like this. This has a special name, which is called as Tp. And those who have taken maths, can you decode STP? Do you know what STP is? Write down this in the comment box. And it's not standard temperature and pressure, remember. Is there anyone who has the idea of STP? Good. T for triple. P for product. S for scalar. You're getting potential difference, which is a scalar quantity. So this thing has a special name which is called, write down, scalar triple product. In short, STP. V cross B dot dl. This is what cross product. The whole thing inside the bracket will give you a vector, which is electric field, minus of electric field. A vector, another vector, they are dot. Dot means what? Scalar. So you are getting a scalar product when you multiply three vectors. This is called STP. And everything inside the boundary is a special result for you, for any examination. Now there is a special property of STP which will help you a lot. Without any proof, I am giving you this. And those who have taken maths, they will learn this thing in maths. Or if I am free, I'll give you the whole thing. Although it's totally maths, you don't need it from my side. A maths teacher will definitely teach you. For bio people, just forget about how do we arrive at the other formats, but you will remember them. This whole thing, first of all, is represented in this form. V, B, dl. So when you keep these three vectors inside these square brackets like this, it tells us what? Take cross product of first two and then finally take dot product with the third one. Now, dV can be arranged in this form: V B dl. And you can show this arrow. This is the trick. The trick says your dV is also B cross dl dot V. Look what happened. The first one was what? VB dl. VB dl. Follow these clockwise arrows. Take cross of these two, dot with the third. That's the first one. Now, instead of this, take these two. Take cross of this and this, and dot of the whole thing to the third one. And this is nothing but B dl V. This is same as this. Note down this, and there is a third one also left. Write down the third one in the comment box. I've given you the two formats. What about the third one? Write down that in the comment box. What is the other order which I can use? Good. The third one will be, you can say this is the first one. They're all same, remember. This is the second one. And now look at the third one. dV. Take these two. They are cross. Which is what? dl cross V. Cross of these two and then dot with the third one. Follow this clockwise loop. Dot B. You can always remember this. 1, 2, 3. 1, 2, 3. 2, 3, 1. 3, 1, 2. 1, 2, 3. 2, 3, 1. 3, 1, 2. Simple. Which is dl next one V, next one B. Now these are standard objective questions. Now tell me, is this thing correct? What do you think about it? dV is This is for mostly for JEE type of thing. You can expect something like this. For NEET and schools, this part. This is something for JEE. It's not difficult. Is it correct or not? Write down yes or no. Good. It is entirely correct. What we have done, look at this. This is VB. If you change the order of these two, if you bring B first, it becomes this. Then you just need to do what? Put a negative sign. In fact, what you are doing, if I write B first and then I write V, then this part, it looks like this. Minus of B cross V dot DL. If you change the order, use a negative sign. This is this. So you don't have to now remember each and every part. Simply write down what VBL. VBL clock. If somebody tells you that B, look here, if somebody tells you B, V, DL, then you are moving in the opposite direction. And therefore to correct it, use a negative sign. And therefore it's a very useful trick. VBL clock. If anything anti-clock happens, simply use what? The negative sign. So tell me, is this thing correct? You can expect questions like these. Is it correct? Yes or no? Fast. Especially those who didn't answer this part, they should try this thing. Is it correct? Good. It's not correct. Why not? You're moving DLB, you're moving DLBV. You're moving anti. If you're moving anti, then you should place a negative sign, which is not present, and therefore it's not correct. We'll see STP, its application, its conversion of this into that standard result VBL in the next class. I hope everything is clear. Put on this and then you can leave. Thank you very much.